In this example, we're being asked to differentiate, which just means find the derivative of this given equation right here, and then they throw in that language with respect to x. That's just telling us the variable that we care about. So when we look at this function to start with, we have the cosine to the third of e to the 3x squared minus 5x plus 7. Before you go rushing straight in to take a derivative, you always need to pause for a moment and look for a handful of different algebraic rewrites that might help you out, or that you absolutely have to do. And this is one of them right here. What we're looking at is whenever you have a trig function raised to a power, that's not really helpful for us when we're trying to find derivatives. And so we need to do a rewrite on that to change it into something we can use. The idea here is basically, so say I had something like sine squared x, I would want to rewrite that by putting that sine function on the inside and raising all of that to that second power right there. And so that's what we need to do here is we're going to keep the cosine of all that stuff inside a set of parentheses, but then we need to raise that whole thing to the third power. So the rewrite here is going to be all this stuff, cosine of e to the 3x squared minus 5x plus 7, parenthesis, and then another parenthesis. All of that is now raised to the third power. So the first move here was just to do a rewrite, and that was to bring that third power to the outside and make it a set of parentheses around the entire equation. From there, what you now need to do is sort of say, what is the primary thing happening here? What derivative rule do I need to be following? Well, anytime we've got sort of special cases of cosines and e's, and then we've got this really big sort of parenthesis raised to a power here, anytime you see those situations happening, this is really telling us that we need to be applying a chain rule. And so my chain rule saying that I like to use goes d in times d out. The derivative of the inside times the derivative of the outside. And what we have going on this problem is we actually have a couple of layers of inside. And so that means, I usually there's a couple of ways of doing this. This is one. If you want to see a second way, I'll show you a second way in another video just after this. But for this one, I'm going to do the inside out method. I'm going to start by saying, okay, inside this 1/3 power is this cosine function. But then inside that cosine function, we have this e function. But then inside that e function, we have this 3x squared minus 5x plus 7. And so what I do is I go to that insidemost piece and I start just working my way from the inside out. So as I do this, my derivative, you just sort of make the derivative as you go. So starting with the insidemost piece, the derivative of 3x squared minus 5x, that's just going to be doing my power rule. So bringing the power down, subtracting 1 from the power. So 2 times 3 gets me 6x, subtracting 1 from the power gets me x to the first. Then we've got an unwritten 1 on that x. We bring that down and we get 1 times negative 5 gets us negative 5. So there's the derivative of that inside piece. I now move out a layer. So I move out to this e function here. And so the e function, that's one of our special case derivatives that you just had to have memorized. I call them special cases. This is e to the x. The derivative of e to the x stays e to the x. So we know that with our special cases, we're always running into chain rules. And so here we've taken the first part of it, and now we need to do the second part. So taking the derivative of e, this would be e, and then you leave alone all the junk that you already took the derivative of. So this 3x squared minus 5x plus 7. Then we move it out another layer. So I move it out from that e, and outside that e is this cosine function. Well, guess what? That's another special case derivative that you need to be able to identify. So if f of x equals the cosine of x, the derivative of the cosine of x is negative sine x. So applying that here, remember when you've got that negative, make sure you put a parentheses. They will love to read that as a minus instead of a times a negative if you don't. So this is negative. The derivative of cosine is negative sine, and then we leave alone all the junk we already took the derivative of. So we leave alone inside here e to the 3x squared minus 5x plus 7. And now we are going to move it out one last time to the outsidemost layer, this piece here, which is this third power. And of course, because this thing is huge, I am running into the other side here. So we're finishing out this chain rule, d in, d out. This is our last out. This is just a big power rule. You bring that 3 down in front. You leave alone all the junk that you already took the derivative of, and then subtract 1 from the power. So subtracting 1 from our power right there. And that's it. That's your final answer for the derivative. So when you've got chain rule inside a chain rule inside a chain rule, go inside out. Find your way all the way, drill down in until you find the insidemost piece, and then just work your way out like layers of an onion, just a layer at a time until you get to that outsidemost derivative. Always leaving whatever you already took the derivative of alone. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.